Okay, so now that we understand the basics of ray casting, I want to talk about how to do this on a scene. So I know how to intersect a ray with a triangle, and I know how to intersect a ray with a sphere. Let's say I had a ray that was going in this direction. It looks like there is a valid point of intersection on the triangle, like maybe right around here, and also on the sphere. So we'll just look at the first point of intersection on the sphere. But the triangle is in front of the sphere, so I wouldn't see the sphere, right? The sphere, we say, is occluded from the triangle. So let me write that word down. So how do we figure out which one comes first? How do I know that I actually need to do the lighting calculation at this triangle and not at the sphere? Well, I could just look at the ray parameters. So let me call this T1, and let me call this T2. So in this case, what I'm saying is T1 is less than T2. So I'm going to use that T. So what rayIntersectScene does, so we can think of this as a method that takes in point P0 on the ray, the direction, and also a scene. And what it does is it says, for each object in the scene, so actually what we'll do is we'll first say, here's my minimum T. We'll say it's infinity. So I'm not intersecting anything. We'll call that infinity. So we'll say for each object, let T be ray intersect object. We'll say P0V object. Okay, so whatever. It's going to be ray intersect triangle, ray intersect sphere, whatever it is. And what we'll say is if T is less than the minimum T we found so far, we'll store away our T, and we'll also store away our object. So I'll say min object equals null. Okay, this is pseudocode, not real code, but I just want to give you an idea of how this works. So if T is less than the smallest T that we've seen so far, well, we've seen something that's closer. So we'll say update that. So min T is equal to T, and minimum object is equal to object. Now do you see why way back when at the beginning of the course I had you do something like this? Okay. So this is how we do something called visibility determination with ray tracing. So we figure out which object do we actually see with this ray. And that's the one I want to do the lighting calculation on. So at this point I can say do the lighting calculation on the object at this point of intersection. So, at P0 plus T min T times V. Okay. So that's how that works. And that's all there is to it. Okay, so let's pause there for a second and take that in.